Hello everyone, welcome to my channel, and I think we have a new circuit here. We have here circuit 1, small LED resistor, and this is a 555 timer. This one, capacitor and the capacitor, LED, some resistor, very nice LED, transparent, red. And the circuit of these two, we have two circuits here. From very far is a blue blinker, some resistor, 555 timer, and a capacitor. So we have two circuits here, blinker LED red and blue blinker here. So we're going to know what makes this LED from blinking. Let us see the circuit here. So we have here a blue blinker and a red blinker here. Let us see the circuit of this blue blinker. And the circuit of this blue blinker is this. LED flasher, and we have a diagram here, and we have parts here. Capacitor, LED, resistor here, IC, 9-volt supply here. And it's very faded already. We have the parts here. And that is the circuit diagram. We can withdraw or modify, or let us make a new diagram, because this is very old. This is our previous circuit. Let us make this new diagram here. And I call this 555 timer LED current sourcing analysis. So the equivalent of this old circuit, previous circuit, is this. We have pin 1 connected to the ground. Pin 2, that is the trigger. This one, trigger, is connected to pin 6. Pin 3, the output. Then cathode side is connected to the output, just like here. The cathode side is connected to the pin 3. Anode is to the voltage supply. Pin 4, that's the reset. That is the reset, connected to the power supply. And then we have pin 5, no connection. Pin 6, that is the threshold, connected. Here is the capacitor, and also RB7, connected is RB and RA, and pin 8 connected to the power supply. So let us examine why the LED is flashing here with this mosquito type of circuit. So hard to construct this type of circuit, and it needs a lot of jumper wires. So let us examine the current flow here. When there's a power supply here, current flows here to the RA, RB, charging the capacitor from RA to RB. So when it is charging, also there is a current flows here at the LED to the output and to the ground. Also current flows here to pin 8, 7, 6, and to pin 2, meeting at the center or inside the chip, and to the ground and to the... When it's charging, the tendency of the current is to flow into the capacitor, and almost the current flows, or the current is absorbed here, absorbing all the current. And since this one is current sourcing, it means LED is connected to the voltage supply. It has its own current supply. So it is lighting even when the capacitor is charging, because it is connected directly to the power supply, and almost all the current supply is absorbed by this capacitor, absorbing all the current supply here, current supply in this NE557, most all of them. When the capacitor is charging, still the LED turns on. So what makes it to turn off? So this one is when charging the capacitor, LED turns on, because the LED is still connected directly to the power supply, and LED is connected to the output. Its cathode connected to the output inside to flow inside the IC and to the ground, back to the source. So when the time the capacitor is discharging, LED turns off. So what makes the LED to turn off? Here, when the capacitor is discharging, he is the one supplying the voltage supply here. So it discharges through RB, RA, and then goes to the inside the IC. Remember, this is integrated circuit. And then flows here to the trigger terminal, and meet there inside the IC. And it flows to the ground, discharged. Why are we not going here, terminal 3? Because this is reverse bias. It's open, negative, positive, so it will not flow here. Also, it can flow here, I believe, but it is not enough to turn on the LED. Why? Because majority of the current is flowing here to the ground. So making the LED to turn off. Majority is flowing to the ground because the tendency of the current, the current flows, is to know or to flow into a lesser resistance. Less resistance here. Other than this, also electron flows here, or the current flows here, but it is not enough to turn on the LED. And so the current flows here, not in here, reverse bias. This, not enough current to turn on. So majority of the current flows here into the ground of the IC with the discharging effect of the capacitor through RBRA. It discharges. This is the discharge terminal 7. So it discharging through here, to here, and also here, and to the ground, shorting this LED. And as the title said, LED current sourcing. It means that LED is getting its current source from the source. Current sourcing. The source current is the voltage source connected to the LED, where it's getting its current supply or current source. That's why they call it current sourcing, when the LED is connected directly to the positive or to the current. That is current sourcing. And let us now go to our next circuit. That is this, the blue-red blinker. And this is the circuit 555 terminal LED flasher. And we have here a battery. When you close the switch, the LED turns on. This one is the yellow or the green LED here. When you close the switch, it just turn on. Have a closed circuit here. And the current flows here to the 8, RA, RB, capacitor, pin 6, pin 7, pin 5. We have here control voltage here. We have here this C2104. And we also on the pin 4, we have this reset connected to the power supply. So the purpose of this reset terminal is just a switch to provide a continuous flow of current through the IC. This is integrated circuit. and 3 is the output. And here it's different. The anode is connected to the output, unlike the previous one. This one, the cathode is the one connected to the pin 3. Here the cathode is connected to the ground and the anode is in pin 3. That's the difference. See the difference? Negative connected to 3. And this our new circuit, negative connected to the ground and the positive connected to the 3. Here the positive is connected directly to the current supply here. So that's the big difference here. In this new circuit, we have the output here, a protector LED of the LED resistor, and then we have here a trigger. That is the trigger connected to the capacitor when it's going to triggering current here. And we have here the ground, just the ground. So that is the circuit diagram of this LED flasher. That is this new one, the red one. Let us examine the current flow of this circuit of this new red LED flasher. And this is the analysis. A 555 timer, LED current sinking. So this one LED is current sinking, and this one LED is current sourcing, and it is very different because of the position of the LED and how the current works here. Let us examine the current flow. So we have here the supply. When you close the switch, current flows here, charging the capacitor. When the capacitor is charging, almost all the current supplies or the current energy charges, voltage supply goes into the capacitor. Almost everything. So still there's a little current flows here to the pin 6, 7, 8. Also here, pin 2. And meet here in the internal circuit of the 555. And it should be flowing here. But since the current is looking for a short way to flow, so it flows to the ground. And since the capacitor is charging, it means less current is inside this chip. So there is not enough current to turn on the LED here. And still there is a current flows here. But a less current, not enough. Because the capacitor is charging. Almost all the current supplies, current flows inside here. But still there is a supply here, but not enough to turn on. That's why capacitor, when charging, LED turns off. Also, current flows here. Less current. Because it is connected to the circuit. So let us see when the capacitor is discharging capacitor, LED turns on. So let us see why. When the source here is the capacitor, since this is discharging to pin 7, RA, 8, 7, 6 through RA, and meet in the center of the IC, and also here, meeting at the center of the circuit. So since this is the one and the LED is forward bias, it will supply a current here. Also current supply is here, less current, but there's a large or maximum output current is supplying here at the IC, so it's enough to turn on the LED here. See? And goes back when the capacitor is discharging. It supplies a current to LED. So when it is charging, the LED turns off. And when it is discharging, LED turns on. And That is, it depends on the value of the capacitor, RA, RB, to change the blinking characteristics of this type of circuit. That is the circuit here. So we now know that in the title it is LED current sinking. Why? Because the LED is getting its power to the negative terminal of the battery, sinking, connected to the negative terminal. When the LED is connected to the positive terminal, that is current sourcing. LED is current sourcing here, but in here, LED is sinking current here, current sinking LED. That is the basic operation of the LED flasher, why it is flashing. So we can also, in this circuit, this one, the red one, we can calculate the values of the protector of the LED. We can calculate it using Kirchhoff's voltage law, and also here. It's the same formula here. Kirchhoff's voltage law, voltage supply, voltage drop. So we got 350 or 500 ohms. So I'm using 500 ohms for these two resistors to protect the LED. And we also calculate the frequency here. What is the frequency of this blinking LED here? Since they are almost identical, the same components, almost, we can calculate that using the formula 1.4 over RA plus 2RB times capacitor. Using that formula, substitution, since this is our RB, that is 1K each, and capacitor of 470, this is 470 microfarad. We got here a frequency of 1.02 hertz. So the blinking frequency here, or the oscillating frequency here, is 1.02 hertz, 1.02 cycles per second. And the blinking time is 1 over frequency, 1 over 1. So it blinks at 0.92 seconds. See, it's almost blinking at 1 second, or 0.92 second, 1000, almost 1 second, both of them. So this one is LED current sourcing. This one is LED current sinking. Let us see the final circuit of this one. We have here pin 1. See, it's current sinking when LED is getting its power to the negative terminal. Pin 1 grounded. Pin 2, that is the triggering from the capacitor, the trigger of the capacitor for the output. Pin 3, the output here. Pin 4, it is, as I've said, it is act as a switch here. When you close the switch here, it provides a continuous current flow. And here we have C2, 104. The purpose of this capacitor ceramic 104, or 0.1 microfarad, connected to the terminal 5, is to stabilize circuit, because once you switch the power on, there's a voltage source here. So this is the one protecting that kind of phenomena or happenings. And 6 is connected to capacitor. 7, almost the same, 1 kilo ohm here. We have, I changed it to 220 ohms, the value of the LED here, instead of 500, because in order to produce a much brighter LED blinker here. Voltage supply of 9 volts, and we got the parts here. This are the parts, LED 104 perf board, and we have a layout here. This is the layout. And timer here, the 2 capacitor, big. That one, and LED here. This one ceramic. This one, and we have timer here, and the two resistor here, and then we have the yellow or the green LED here, and then the two resistor here, and we have the two resistor here, and that's it. So in conclusion, the one who is responsible for the flashing of the LED is the capacitor and the resistor, and it depends on the value of the two. When you change the value, it has different blinking characteristics. And that's our new circuit, and thank you for watching my video. Bye bye.